Hey fellow developers, welcome to Mastering Your Code, a technical deep dive into AI coding assistance. It's great to have you here as we unpack the tools reshaping our craft. Imagine your workbench with intelligent power tools. These AI coding assistants, Cursor, Claude Code, Windsurf, augment your workflow. Their purpose? To elevate efficiency and tackle complex tasks with precision. Think of it as a master craftsman equipping his bench with the perfect set of integrated tools for seamless flow. At their core, these assistants are powered by large language models, or LLMs, specifically, sophisticated transformer architectures, trained on vast code and natural language datasets. This isn't just pattern matching. It's learning the syntax, semantics, and idioms of programming. They process tokens, predict sequences, generating remarkably human-like code. So how do they interact with your codebase? Primarily through context windows. When you prompt, the assistant takes your current file, relevant neighboring files, even project structure, tokenizes it, and feeds it to the LLM. This allows understanding of local context, dependencies, and architectural patterns before suggesting code. You might be thinking, how deep does that context go? It varies by model. This contextual understanding enables key interaction patterns. Beyond autocomplete, they excel at boilerplate generation, complex refactoring, and explaining legacy code. I've seen teams drastically reduce onboarding time by having junior developers use these tools to quickly grasp unfamiliar enterprise codebases, converting abstract design docs into concrete implementation stubs with impressive accuracy. These tools aren't isolated. They integrate seamlessly into your modern development stack through IDE extensions for VS Code or JetBrains, or via APIs connecting to CI/CD pipelines. They become integral. They act as a co-pilot, not a replacement, allowing faster iteration, earlier error catching, and consistent code quality across large projects. Crucially, AI coding assistants move far beyond simple autocompletion. They leverage LLM architecture for advanced code reasoning. This means tackling multi-file refactors, synthesizing unit tests, or even translating logic between languages. They understand architectural implications, enabling more intelligent, holistic suggestions across your project. Ultimately, these assistants represent a new paradigm. They're powerful force multipliers, enhancing productivity and consistency. Understanding their technical foundations, from LLM architecture to contextual interaction, is key. Next, we'll dive deeper into a feature-by-feature comparison, laying bare the technical capabilities that truly differentiate each tool. After laying the foundational groundwork, it's time to get pragmatic. Just as a master craftsman's workbench needs the perfect set of power tools, each optimized for specific tasks, we need to compare our AI coding assistants on their core technical capabilities. First, let's scrutinize code generation quality and language and framework support. This isn't just about spitting out code. It's about generating idiomatic, secure, and correct code that minimizes post-generation refactoring. Does it understand the subtle nuances of Rust's ownership model or the async patterns in Python? How broad is its reach across frameworks like React, Spring, or TensorFlow? High-quality generation drastically reduces the cognitive load and potential security risks, ensuring you're not just moving complexity around, but genuinely reducing it. Next, we examine their prowess in refactoring capabilities and debugging assistance. You might be thinking, AI-generated code, isn't that just adding another layer of abstraction and potential complexity? Absolutely, if not done well. But the best tools don't just generate, they refine. They identify code smells, suggest optimal patterns, and automate boilerplate transformations. In real systems, this shows up when a legacy codebase with decades of spaghetti logic needs modernization. An AI assistant's ability to help untangle dependencies or identify root causes in a stack trace can turn weeks of frustration into hours of focused problem solving. Finally, we turn to test generation and extensibility via plugins or APIs. Reliable code is tested code. Can your AI assistant generate robust unit and integration tests, complete with mocks, significantly accelerating your TDD workflow? And beyond its out-of-the-box features, how well can you customize it? Does it offer open APIs or a rich plugin ecosystem to integrate with your unique CI/CD pipelines, custom linters, or domain-specific language tooling? This extensibility is crucial for truly embedding these power tools into your bespoke development environment, making them not just helpers, but genuine workflow accelerators. Understanding these technical trade-offs is key to choosing the right tool for your specific craft, moving us closer to mastering our code. After comparing the technical capabilities of these AI copilots, the real question becomes, how do they actually transform your daily grind? This is where the analogy of equipping a master craftsman's workbench truly comes alive. Each AI assistant is a specialized power tool designed to tackle specific coding challenges with surgical precision. Let's start with boilerplate, that repetitive, mind-numbing setup code for new features or components. Whether it's a new API endpoint in Go or a React functional component with hooks, AI assistants excel here. They can scaffold entire structures, saving you hours of repetitive typing and ensuring consistency across your codebase. It's like having an automated jig for every standard cut, reducing setup time dramatically. Then there's the realm of complex algorithms. Picture a moment where you're tasked with implementing a sophisticated graph traversal or an optimized search function, and you're staring at an empty file, wondering where to even begin. Instead of hours of documentation diving, you can prompt your AI assistant. It can generate initial drafts, explain the underlying logic, and even suggest performance optimizations, effectively giving you a strong foundation to build upon. Cross-language translation and migration is another powerful use case. Imagine moving a critical utility function from Python to Rust, or trying to understand a legacy Java module when your primary language is JavaScript. The AI assistant can act as a universal translator, not just converting syntax, but often suggesting idiomatic patterns unique to the target language, avoiding direct, often clunky, literal translations. And let's not forget refactoring and code quality. Many developers express concerns about AI introducing complexity or even security risks, but these tools can actually mitigate those concerns. You can prompt them to refactor a convoluted function for readability, identify potential security vulnerabilities like SQL injection patterns, or suggest adherence to specific coding standards. It's a proactive step towards a cleaner, safer codebase. Finally, the often dreaded task of test generation. Writing comprehensive unit and integration tests is crucial, but incredibly time-consuming. AI assistants can analyze your existing code and generate intelligent test cases, often covering edge cases you might have overlooked. They accelerate your test-driven development, allowing you to build robust features faster, with greater confidence. So how do these specialized tools integrate into your existing development environment? That's what we'll explore next. After exploring how AI coding assistants can tackle specific coding challenges, the next crucial step is equipping your master craftsman's workbench with these powerful tools. It's not enough to just have the tools. They need to be seamlessly integrated into your existing flow, becoming an extension of your thought process, not a distraction. This integration is where the true leverage lies, transforming your development environment into a highly efficient co-pilot station. For many of us, VS Code is the daily driver. Integrating AI assistants here is typically straightforward, often via dedicated extensions that hook directly into the LSP and editor APIs. You'll want to configure these extensions carefully, ensuring they respect your project's linting and formatting rules, preventing conflicts, and maintaining code consistency. It's about making the AI feel native. Similarly, JetBrains IDEs like IntelliJ, PyCharm, or WebStorm offer robust plugin ecosystems. Here, the integration might involve specific AI assistant plugins that provide deeper, context-aware suggestions, leveraging JetBrains' powerful semantic analysis. The key is to configure per project settings, ensuring that each repository benefits from a tailored AI experience, learning and adapting to its unique codebase and conventions. Now, beyond the IDE, how do these tools fit into your broader development pipeline? Picture a moment where a critical pull request is blocked because of minor style violations, or even subtle security vulnerabilities that static analysis missed. Integrating AI into your build systems and version control via pre-commit hooks or CI/CD pipelines, acts as a proactive gate. It can scan generated or modified code for adherence to standards, identify potential issues before merge, and even suggest automatic fixes, catching issues before they ever hit main. You might be thinking, how do I securely connect these assistants? API access and proper authentication are paramount. Whether it's OpenAI, Anthropic, or a self-hosted LLM, understanding how to manage API keys, ideally through environment variables or secure secrets management, and setting rate limits is vital. This ensures both secure operation and cost management, preventing unexpected token usage. Customizability is where these assistants truly shine for developers. Generic suggestions are fine, but imagine an AI that understands your internal DSL or your specific architectural patterns. Through prompt engineering, exclusion rules, and fine-tuning options, you can tailor the AI's behavior, teaching it your preferred coding style, framework idioms, and even project-specific nuances. This isn't just about code. It's about codifying your team's collective intelligence. Mastering these integration patterns ensures your AI copilot is always ready, always relevant, and always aligned with your project's needs. It transforms AI from a novel tool into a fundamental part of your technical infrastructure. But what happens when we push these integrations to their limits? Next, we'll dive deep into performance benchmarks, latency, and resource consumption, understanding the tangible impact these tools have on your system's efficiency. Now that we've wired up these powerful new tools to our craftsman's workbench, the natural next step is to evaluate how they actually perform in the real world. We're talking objective analysis, not just marketing claims. This means diving deep into benchmarks, understanding latency, and scrutinizing their impact on your local development environment. First up, code generation velocity and, crucially, accuracy. Raw speed is easy to measure. How quickly does the assistant spit out a suggestion or a block of code? But that's only half the story. If the generated code is syntactically correct but semantically flawed, requiring significant refactoring, then that initial speed is deceptive. We need to look at accuracy rates across different languages and frameworks, assessing how often the generated suggestions are actually useful and correct right out of the box, versus how often they introduce subtle bugs or require heavy manual intervention. Because, you might be thinking, what's the point of speed if I spend more time debugging AI mistakes? It's a valid concern. Then there's latency, the delay between your prompt and the assistant's response. A few hundred milliseconds might not sound like much, but picture a moment where you're in a deep coding flow, trying to quickly iterate on a problem, and the assistant introduces a noticeable stutter. That friction can be surprisingly disruptive. We'll examine token generation rates and overall response times. But also, how much do these tools hog your local machine's resources? Are they spinning up background processes that chew through CPU and RAM, slowing down your IDE itself? A sluggish development environment due to an overzealous AI assistant defeats the purpose of productivity. Ultimately, selecting your AI copilot involves a series of critical performance trade-offs. Do you prioritize lightning-fast suggestions, even if it means a slightly higher correction rate? Or do you opt for slower but near-perfect code blocks? Understanding these tools, compute requirements, whether they run locally or rely heavily on cloud-based LLMs, is paramount. This impacts not only your development experience, but also your budget. Which brings us perfectly to our next discussion: the often overlooked implications of LLM costs and execution models. Alright, so we've benchmarked performance and understood latency. But what about the elephant in the room for many developers? The cost. When we talk about ACI coding assistants, particularly those powered by large language models, the conversation inevitably turns to tokens. Think of tokens as the fundamental unit of consumption. Not just words, but often subword units, or even characters. Every prompt you send, and every line of code the AI generates in response, gets broken down into these tokens. And you're charged for them. Different models, even from the same provider, have varying token costs. It's like a master craftsman equipping his workbench. Each power tool has its specific fuel consumption rate, right? Your high-powered router uses more juice than a simple drill, and you factor that into your project budget. Now, these token costs aggregate based on the API pricing models of each provider. You'll primarily encounter pay-as-you-go structures, where you only pay for what you use, down to the individual token. However, some platforms offer tiered pricing based on usage volumes, or even enterprise-level agreements that might include specific rate limits and dedicated infrastructure. Understanding these models is critical, because what looks like a small per-token cost can quickly accumulate when you're generating extensive documentation, refactoring large code bases, or debugging iteratively. It's not just about the raw price, but how your actual usage pattern fits the vendor's billing structure. Most popular AI coding assistants operate predominantly in the cloud. This offers immense benefits: virtually unlimited scalability, zero local hardware overhead for processing, and often superior performance due to specialized infrastructure. However, this convenience comes with a trade-off. You're inherently introducing network latency with every API call, and crucially, you're always paying a recurring fee for those cloud resources and API access. For many teams, the operational ease and powerful models available outweigh the direct financial costs, especially for complex tasks that require massive compute. But you're tied into that vendor's ecosystem and their pricing fluctuations. Conversely, running an AI assistant locally, often with smaller, open-source models, flips this equation. You gain unparalleled control over data privacy, as your code never leaves your machine. There are no per-token API costs, making it incredibly cost-effective in the long run after the initial hardware investment. This is where the analogy really shines. A craftsman might invest in a heavy-duty, expensive piece of machinery for their workshop because it offers precise control and zero recurring rental fees for its usage. However, you're responsible for managing the hardware, keeping models updated, and you're limited by your local machine's processing power. I've seen teams invest heavily in high-end GPUs only to find their local model inference still lags behind cloud APIs for certain tasks, leading to developer frustration if expectations aren't managed. This brings us to the hybrid approach, which is increasingly becoming the sweet spot for many. The idea is to judiciously use local models for sensitive data or boilerplate tasks where speed and privacy are paramount, while reserving cloud-based AI for highly complex code generation, sophisticated refactoring, or access to cutting-edge models that demand significant compute. This allows you to cherry-pick the strengths of each, mitigating the downsides. You might run a local LLM for immediate autocomplete suggestions and basic syntax checks, but push a larger, cloud-based prompt when tackling a thorny architectural problem or generating comprehensive test suites. It's about creating a workbench where every tool is used for its optimal purpose. Beyond the direct token costs, the true value of an AI coding assistant lies in its return on investment. Are you saving significant development time? Are fewer bugs making it to production due to AI-assisted code reviews? Or better test generation? Is your project velocity increasing? These are the metrics that justify the spend. It's not just about how much does this API call cost, but how much did that API call save me in developer hours, in deployment cycles, or in reduced post-release fixes? You might be thinking, how do I even measure that accurately? Well, tracking metrics like code generation time versus manual coding time, or bug density before and after AI adoption, are a great start. So with all these factors in mind, how do you manage and optimize these costs? Strategic prompt engineering is crucial. Concise, effective prompts use fewer tokens. Implementing intelligent caching mechanisms can prevent redundant API calls. Choosing the right model for the task, not always the largest or most expensive, can drastically cut costs. And of course, rigorous budget monitoring and setting spending alerts are non-negotiable. This isn't just about being frugal. It's about being a smart engineer, just like a craftsman who knows exactly which power tool to pick to get the job done efficiently without wasting resources. Mastering these aspects will directly impact your project's bottom line. Up next, we'll shift our focus to an equally critical concern: the security risks and code quality considerations that come with relying on AI-generated code. After understanding the costs, let's turn our attention to one of the most critical aspects of integrating AI coding assistants: the security and quality of the code they generate. It's a powerful new addition to our master craftsman's workbench, undoubtedly. But like any new power tool, it comes with responsibilities and potential pitfalls we need to master. AI, while brilliant at pattern matching, can inadvertently replicate or even introduce subtle security vulnerabilities. You might be thinking, surely it's smarter than that? But remember, these models learn from vast datasets, which often include real-world, imperfect code. This means insecure patterns like SQL injection, cross-site scripting, XSS, or improper authentication flows can slip into your codebase, especially when the AI lacks full context. Beyond outright security flaws, AI-generated code can also present significant quality issues. We're talking about correctness. Is it actually doing what you intend? Maintainability. Can your team understand and evolve it? And even obscurity or over-engineering, where a simple solution becomes a complex, unreadable mess because the AI chose the most common, but not necessarily the best, pattern. In real systems, this shows up when a seemingly harmless AI-generated utility function designed to handle user input inadvertently leaves an application wide open to SQL injection because it didn't sanitize inputs thoroughly. Or, an AI might provide a boilerplate solution that, while functionally, uses deprecated libraries or inefficient algorithms, leading to technical debt before the code even ships. So how do we mitigate these risks? First, by adopting proactive security integration. This means shifting security left in your development lifecycle. Integrate static application security testing, or SAST, and dynamic application security testing, DAST, directly into your CI/CD pipelines. Tools that scan dependencies for known vulnerabilities are also non-negotiable. Second, we must enhance our code review processes. Human oversight remains paramount. Treat AI-generated code as a starting point, not a final solution. Pair programming can be highly effective here. Develop clear review checklists specifically for AI output, focusing on security best practices, adherence to coding standards, and importantly, the why behind the AI's suggestions. Test-driven development, or TDD, also becomes even more crucial. Ultimately, building a resilient, AI-augmented workflow requires continuous learning and a strong sense of developer responsibility. AI coding assistants are powerful co-pilots, but you, the developer, are still the pilot. Understanding their strengths and weaknesses, integrating rigorous testing, and maintaining robust review processes are key to harnessing their power safely. Speaking of harnessing power, in our next scene, we'll explore how you can customize and fine-tune these tools for your specific project needs. Now, we've covered security and quality, but what if the AI assistant isn't quite hitting your team's specific style? Or it's missing crucial domain knowledge? This is where customization becomes your most powerful lever. Think of it this way. Our central analogy equips a master craftsman's workbench with the perfect set of power tools, but even the best tools need to be calibrated to the specific wood, the specific joint, the specific project. A generic setting just won't cut it for a bespoke masterpiece. Your AI co-pilot is no different. You might be thinking, but isn't AI supposed to just know? Well, it knows a lot, but its default output is often general purpose. Your first line of defense is basic configuration. Adjusting parameters like temperature for creativity, top for diversity, or max tokens for length can significantly steer the output towards your immediate needs. This is about making the tool respond better, setting its fundamental behavior. The real art, however, often lies in prompt engineering. This isn't just about asking nicely. It's about structuring your requests with precision by providing clear context, defining specific roles for the AI, imposing strict constraints, and offering concrete few-shot examples. You're not just asking for code. You're teaching the model how to think and generate code within your specific universe. It's about clarity of intent. I've seen teams struggle immensely when trying to refactor monolithic legacy systems using generic prompts. The AI often introduces modern patterns that clash with the existing architecture, but through iterative prompt refinement, where they explicitly fed examples of the legacy design patterns, the AI began to understand and generate compatible, context-aware refactorings. It transformed from a general assistant to a project-specific architect. Beyond just prompts, many advanced tools offer extensibility through APIs and plugins. This is where you can connect your AI copilot to internal knowledge bases, proprietary libraries, or even custom linters. Imagine your AI not just generating code, but also automatically querying your company's architectural guidelines, or integrating with your build system to pull context. This is about expanding the tool's reach. For truly unique project needs, consider fine-tuning. While more resource-intensive, Fine-tuning an LLM on your specific codebase, internal documentation, or domain-specific languages like embedded DSLs transforms it into an expert in your exact universe. It learns your idioms, your edge cases, and your preferred solutions, effectively becoming an extension of your team's collective wisdom. It's an investment, but one that pays dividends in precision. Finally, implementing guardrails and style guides is paramount. This ensures that even customized or fine-tuned AI outputs still adhere to your team's security best practices, coding conventions, and architectural principles. It's about automating compliance, making sure your custom power tool is always used safely and effectively. Next, we'll talk about how to choose the right AI copilot for your specific workbench. We've refined our prompt engineering and even fine-tuned models for domain-specific tasks. But ultimately, the real power lies in choosing the right copilot for your unique workbench. That perfect set of power tools that truly enhances your craftsmanship, not hinders it. First, you need to consider the foundational compatibility. Does the AI assistant deeply understand your primary programming languages and frameworks? We're not just talking basic syntax here, but nuanced idiomatic code generation for, say, a complex React component with hooks, or an asynchronous Rust service. The quality varies significantly, and a mismatch here can introduce more bugs than it solves. You might be thinking, but what about my existing CI/CD or my specific IDE? Exactly. Seamless integration into your current development environment is non-negotiable. An AI that forces you to context switch constantly or struggles with your custom build system becomes a bottleneck, not an accelerator. Look for native plugins, robust API access, and configurable hooks that respect your existing flow. In real systems, this shows up when teams choose an AI primarily for its low cost, only to find its code generation frequently introduces subtle security vulnerabilities, like SQL injections or unoptimized data structures. The immediate saving is quickly dwarfed by the cost of refactoring, security audits, and debugging. You need robust code quality and, critically, explicit security guarantees, especially if you're dealing with sensitive data or critical systems. Don't let AI abstractions increase your attack surface. Next, performance and latency. There's nothing more frustrating than waiting seconds for a code suggestion when you're in flow. Evaluate not just its raw generation speed, but its responsiveness within your IDE, its resource consumption, and how it handles larger code bases. A fast but resource-heavy tool can degrade your entire development experience. Then, consider customization and extensibility. Can you tailor its behavior to your team's specific coding standards, style guides, or even proprietary libraries? Advanced prompt engineering and custom fine-tuning capabilities, as we explored previously, transform a generic assistant into a truly personalized copilot for your particular project needs. This flexibility is crucial for long-term adoption. And let's be transparent, the underlying LLM costs. This is a key concern for many of you. Understanding the token pricing models, how usage scales, and the implications of local versus cloud-based execution is vital for budget forecasting. A tool might seem affordable initially, but unchecked usage can quickly escalate expenses, impacting your project's ROI. Finally, don't overlook the community and support ecosystem. A vibrant community means better documentation, faster bug fixes, and a rich library of shared prompt engineering wisdom. Active forums and responsive vendor support are critical for resolving issues and staying updated with the latest advancements. It's about more than just the tool itself. It's the network around it. Next, we'll explore resources for further learning and how you can actively engage with the evolving AI coding assistant community. Stay tuned. So you've carefully selected the perfect AI coding assistants, much like a master craftsman equipping their workbench with the ideal power tools, each optimized for specific tasks. But the journey doesn't end there, does it? To truly master these tools and to stay ahead in this rapidly evolving landscape, continuous learning and engagement are paramount. You might be thinking, I've made my choice, now what? The what is deepening your expertise. Your first stop, always, should be the official documentation. These aren't just dry manuals. They're the authoritative blueprints for understanding APIs, configuration nuances, and the latest features. Dive into the developer guides, explore the SDKs, and pay close attention to release notes. This foundation is critical for robust integration and troubleshooting. Beyond the docs, the real-time pulse of the AI assistant ecosystem lies within its community. Engage on GitHub discussions, join official Discord servers, or explore Reddit threads like r/developers. These are invaluable spaces for crowdsourced solutions, discovering new patterns, and understanding common pitfalls. It's where you find the practical wisdom that doesn't always make it into formal guides. And for those looking to truly contribute and deepen their understanding, delve into open-source projects. Many AI coding assistants have open-source components, plugins, or even full frameworks. I've seen teams unlock incredible custom capabilities by understanding these projects, identifying issues, and even contributing pull requests. This hands-on engagement is the fastest way to grasp the architectural decisions and internal workings. For a more structured, advanced learning path, consider specialized online courses focusing on LLM prompt engineering, or even academic papers on AI-assisted development. Platforms like Coursera, edX, or even specific vendor-provided certifications can elevate your expertise from intermediate user to domain expert. Understanding the why behind the AI's suggestions empowers you to leverage it more effectively. Ultimately, staying sharp means never stopping your exploration. The AI coding assistant landscape is dynamic, and your workbench will need new tools and upgrades constantly. Keep experimenting, keep sharing, and keep building. Thank you for joining me on this deep dive into mastering your code with AI assistants. If you found value in this discussion, please hit that like button to support the channel. What's been your biggest surprise or challenge with AI coding assistants so far? Share your insights in the comments below. I read them all. And if you want to continue leveling up your development game, subscribe and hit the bell icon for more expert content. Don't forget to grab the full playbook.